Hi, today we are going to see about computing paradigm in PCCF. What is the computing paradigm? It is a model or pattern that defines how computing processes are structured, executed, and managed. So each paradigm reflects technological evolution to improve efficiency, speed, scalability, and collaborations. We will be having over the years different computing paradigms have been developed and used. In fact, different computing paradigms have existed before the cloud computing paradigm. So we will be having so many paradigms that is computing paradigm. So the first one is client server computing. So what's client server computing? A client and a server, communication between client and server. So this is a computing model in which tasks are divided between clients, that is request, and servers, which is providers. The server provides resources or service while the client send the request and it will be using the results. So there are some key features in client server computing, which is a centralized service delivery, communication through network protocols, and servers can handle multiple clients immediately in the client server computing paradigm. And some advantages like data and security is very much good, and it is very easy to maintain, and we can easily share the resources across clients. And the disadvantages is the server will be overloaded. It can reduce performance. So while the server can be overloaded means it will be reducing the performance also. And it requires constant network connection. If the network is not there means it will be come under problem. So some examples are email servers and clients. The next one is parallel processing, which means parallel computing, which is defined as a type of computing where multiple computer systems are used simultaneously. So here our problem is broken into subproblems. So and then further broken into instructions. These instructions from each subproblem are executed concurrently on different processes. That is executions of multiple instructions or tasks simultaneously by dividing a program into smaller parts processed in a parallel. So these key features are it utilizes multiple process or host tasks can be independent, they use in a high performances, and here the types we are using is data parallelism and task parallelism, which means same operations on different data, which is known as data parallelism, and different operations on different tasks is known as data task parallelism. So we are having some advantages and disadvantages of this particular thing, which is faster computation, efficient of use, and the disadvantages is complex to design and debug. So it will be coming under overhead in coordinating process also. The next one is multiprocessing. Multiprocessing is nothing but a system which has two or more CPUs that share memory and perform multiple processes simultaneously. So, which is known as multiprocessing systems. We will be having two types. One is symmetric and asymmetric. So, all CPUs share memory equally in symmetric process, and one CPU is the master, and others are slaves in asymmetric processing. So these advantages are it increase system reliability and performance, and it support multitasking, and it reduces the processing time also. The disadvantages is more expensive hardware, complex process synchronization, etc. So next one is distributed computing. Here multiple independent computers work together to perform a large computations conducted through a network. So, resource sharing across locations is very easy and high availability and requires coordination through the middleware. Some advantages and disadvantages. It is very scalable and reliable, which is very cost effective, and it enables collaborations. And some disadvantages are network latency, difficult error handling, and synchronizations also. So the next one is grid computing. Grid computing is nothing but it combines distributed resources from multiple locations to solve large scale of scientific or technical problems, which is a type of computing where it is constitutes a network of computers that work together to perform tasks that may be difficult for a single machine to handle. So all the computers on that network work under the same umbrella, and it is termed as a virtual supercomputer also. The task they work on is either high computing power or consist of large data sets. So all communication between the computer system and grid computing is done under data grid. So the advantages of grid computing is high performance, and it is very low cost, and it is very scalable and flexible. So disadvantages is complex resource management and depend on network performance, etc. So the next one is hybrid computing. Hybrid computing is nothing but it combines different computing models like client server, cloud, and grid computing to achieve optimized performance. So, this is actually used for loading and improving the reliability, flexible resource allocations, and cost efficiency is good than this one, and greater control and scalability. So disadvantages is nothing but integration complexity, security management across multiple environments. The next one is cloud computing. Cloud, what is cloud computing? So it is defined as usage of someone else server to host, process, or store data. It is defined as a type of computing where it is a delivery on demand computing services over the internet on a pay as you go basis. So it is widely distributed, network based, and used for storage also. There are types of clouds, which is public, private, and hybrid or community. Some cloud providers also are there, which is Google Cloud, AWS, Microsoft Azure, and IBM Cloud. So we will be having service models, which is IaaS, that is infrastructure as a service, PaaS, platform as a service, SaaS, this is software as a service. These are ready to use applications, and those advantages on demand, scalability, cost effective, pay as you go model. So, how much you can pay, you can use. And disadvantages is data security, privacy concerns, dependence on internet connectivity. The next one is mobile computing, which is a technology that allows transmission of data, voice, video, and wireless networks while on move. So it is very portable and wireless too. So the advantages of real time is to access informations, real time flexibility, and supports IoT. And disadvantages is battery and resource limitations very low, and it is having a very risk and security purposes. So some future computing techniques such as coming under emerging trends, quantum computing, edge computing, fog computing, neuromorphic computing, and green computing. Thank you.